All right, we're going to start on the acceleration and the forces part of the semester review. For acceleration, your formula is going to be acceleration equals the final velocity, which is VF, minus the initial velocity, which is VI, divided by time. Okay, this will be given to you on a formula chart. So let's start. A car went from 20 miles per hour to 80 miles per hour in 3 hours. What was the car's acceleration? Well, our initial velocity is 20 miles per hour. It gets up to 80 miles per hour, so that's our final velocity in 3 hours. That's our time. Plug it in. Acceleration equals VF is 80 minus VI is 20 divided by the time, which is 3. So we end up with 80 minus 20, which is 60, divided by 3 is 20 miles per hour squared for acceleration. Okay, 20 miles per hour squared on that one. Next one, a boat accelerated from 3 meters per second to 12 meters per second in 4 seconds. What was that should say boat's acceleration? All right, so we start from 3 meters per second, that's VI. We get up to 12 meters per second, that's VF, in 4 seconds. There's our time. Plug it in. Acceleration equals VF, which is 12, minus VI, which is 3, divided by T, which is 4. We end up with 12 minus 3, which is 9, divided by 4. If we simplify that, we end up with 2.25 meters per second squared. Hope y'all can see that. 2.25 meters per second squared. All right. Forces. These are free body diagrams. We want to be able to say what the magnitude is on the forces below. All right, so we have a 5 Newton force going to the right, a 5 Newton force going to the left, so those two cancel each other out. We're left with a 5 Newton force going down, so we end up with 5 newtons of force going down. Okay, that's our net force. What is the magnitude and direction of the net force on the object below? We have 5 newtons going to the left, 5 newtons going to the right, so those two cancel each other out. We have 5 newtons going up and 5 newtons going down. Sometimes you will see the force going up called the normal force. Okay, you need to know this word. The normal force is the force that keeps us from falling through the ground. Okay, when gravity pulls us down, so you'll have the gravitational force. That pulls us down to hold us on the ground. The normal force is pushing back up against us. That keeps us from falling through the ground. All right, so these two forces just so happen to cancel each other out as well. Okay, make sure you guys know what a normal force is. Okay, it's the force that opposes the gravitational force. All right, number 3, what is the magnitude? So basically we have no net force on this. No net force. Everything cancels each other out. All right, what is the magnitude and direction of the net force on the object below? Well, we have 5 newtons going to the right, 3 newtons going to the left. So we're left with 2 newtons of force going to the right, but then we still have to look at this 2 newtons of force going up. All right, so we still have 2 newtons of force going up as well. All right, so this is unbalanced. It's going to move a little bit to the right and a little bit up, so it would go something like that. Unbalanced. Okay, and those are your net forces and free body diagrams.